I'll spare you with my full name. I work for Microsoft. It's a fairly new role. Shameless plug. You know what? I think I was told not to use black slides, so I'll use the white slides. See, I read the 10 Commandments, so there you go. We're hiring, so if you're interested in working for Microsoft, find me. My boss will be very happy about that. I also need to acknowledge that I'm a dad and a husband, because my wife, I need to take a special permission from my wife to attend this event. So obviously she does all the hard work with the kids. And I'm also a geek, coder, and breaker of things, not a maker, as most people like to say, because I tend to break loads of stuff. And finally, I work with a lot of open source. If you want to get in touch with me, I'm always on Twitter, and you can email me about anything that has to do with code, non-code, and personal life problems. Happy to solve them. So OSS, open source. This is me on a Friday night, sitting down when everyone's back to sleep, and I've got some free time in my hands. I'll let you read this one because it's. Can you guys at the back read this? Good. Right. So the next one. Starting another side project. I've got tons of side projects, tons of half-finished things on GitHub and everywhere else, and I like to get my hands on lots of pies, and that's why we're here today. I am here to speak to you about TypeScript and JavaScript. Can I get a show of hands on how many people know about TypeScript? Okay. How many people use JavaScript on a day-by-day basis? .NET developers? Don't be ashamed. We're still cool. Actually, .NET Core made everything worthwhile, so let's get started. Jeff Atwood said, everything that can be written in JavaScript will eventually be written in JavaScript. You all know that, right? In fact, I think I have a nice thing to show you here. I have JS Linux. Let me just... So do you know what this is? Let me just make it slightly bigger. This is Linux running in JavaScript. It's not indeed. I hate it when PowerPoint does that. I need to come out from PowerPoint. Yeah, there you go. So let me just bring back my beautiful, beautiful emulator here. So this is JavaScript on running Linux. And in fact, it's a full operational Linux machine. So if I do cut and that and say test.txt, just going to create a text file. Hello, Newcastle, lowercase. No, you don't mind. It's JavaScript anyway. You're all awesome. And stop that. And then we can read it with cut test.txt. How freaking awesome is that, right? That's actually, you can write C++ code, compile it with GCC, and then output an exe file that you can run on that machine. So that's insane. That's what Jeff meant when he said everything that can be written in JavaScript will be. And in fact, we're getting JavaScript assemblies as well, so that will be even better. And that's sometimes can be also a bit of a problem. We all know that. For those that have not really woken up yet and smelled the coffee, JavaScript has won the world. It's not Java or C++ or Ruby or Go or anything else. We have JavaScript running everywhere. Desktop, phones, anything that you can think about, it's there. And it's extraordinary to think about where the journey began a few years ago. And 1995, when the Netscape team sat down in response to the dominance of Java at the time, they said, well, we need to come up with something quickly. Let's get some prototype out there. 10 days, put something together, JavaScript, boom, ship it out. It's a prototype, we don't have to worry about that. In fact, nobody's going to run more than a few hundred lines of code, right? And now we have quite a few things. We have, who you just like in here? Yes, JavaScript. A few memory leaks, but runs fine. You just need lots of memory. We have Gmail. We have Atom. So Atom, it's a cell that allows you to write code. It's all written in JavaScript. And then we have Visual Studio Code, which was written with TypeScript, Angular, and JavaScript to allow you to write and do code as well. So you can write JavaScript within the JavaScript within JavaScript. It's inception. So JavaScript is everywhere. However, the dominance came so quickly that we now have quite a few problems. There's nothing wrong with JavaScript being everywhere. However, it's not the language that we would like to have as a dominant one, but it's the language that we have. So how do we make it work? And since the JavaScript applications are becoming so big and so dominant, we do now have enterprise scale JavaScript. I mean, everywhere that you go these days, banks, small shops, they all use JavaScript for something. And the problem is, how do you organize that? How do you make it work for you? And what happens once you start having more than 2,000, 3,000, 4,000 lines of code? How do you refactor your files? How do you work with them? How do you reference them in a nice way? Now, obviously, JavaScript has come a long way to now get ES 2015, and then we're having the ES Next, or 2016, 2017, that are adding a lot of features that we're missing. However, the stopgap was nothing out there. So things came up. Things that help us address the problems like refactoring, building components, like classes and interfaces that were not present in JavaScript, static typing, which is quite important, and go to definition, renaming, and refactoring, and changing things around your code. So yeah, JavaScript is nice, and it's quite loosely typed and so on. However, when you write massive applications that you need to know that the code you're referencing is a specific type, then this is something that was specifically missing. And then we had ECMAScript coming in. As I said, 2015 is already ratified and it's out there, and we already have 2016 being worked, ES7. However, they're adding issues they're adding features slowly, in a slower pace or cadence as you would like them to be, and they still have missing features. And the biggest problem is browser adoption. Now, obviously, ES6 is already quite adopted in most browsers, so especially Chrome is way out there, and then you have Edge and other Chakra engine and so on that do work. However, we do have charts that say, well, the adoption is not up there, and you want to be able to use the latest and greatest, async, lambdas, static typing, and so on. So you had this, and then we had compilers and polyfills that came in to fill the gap. So that's the stopgap in between. So we have Babel, which allows you to write in a specific way, and then it transpiles that into proper JavaScript, the ES5 JavaScript that most of the browsers will understand, and that was the biggest issue. Then we have Tracer, or Tracer, however you want to pronounce that, and TypeScript. TypeScript is the one that we're going to be speaking about today. So has anyone of you used it in a production environment? No one. Wow. One. Way. Good. I used it. It's a bit of a learning curve. But today, what I'm planning on doing is, rather than killing you with PowerPoint slides, which I have quite a few of them, in fact, we're going to go through them quickly in the first part. And then in the second part, we'll do a lot of demos just to show you what the language can offer you and how you can use it to your benefit. And then hopefully, living out there, it will give you enough foundation to go out there and try it for yourself on top of your existing JavaScript, or even in proof of concepts, to allow you to get the benefits out of it. So TypeScript is a language for large-scale JavaScript development, and it was created by Anders Hellsberg. So he's the creator of .NET C#. You guys know C#? Some of you? .NET? Yeah, cool. So he's the guy that worked on that project, and then he said, right, I'm going to leave and create something else. And he did start as a project back in internal project in 2010, and it was publicly released in 2012. And it actually was released as a typed superset of JavaScript, which compiles down to plain JavaScript. However, the secret is that TypeScript is pure JavaScript. So you can just write JavaScript within your TypeScript files, and it will compile nicely to JavaScript. So the only difference between the two things is just the file extension. So file.ts will be your TypeScript file, and it can contain perfectly clean vanilla JavaScript without any special characters or special words or reserved words. And you also have then the proper TypeScript language features that you can use on top of that. However, remember that TypeScript is plain vanilla JavaScript, and we'll understand that. And I also like TypeScript because not only you can write plain vanilla JavaScript, but it will also compile to or transpile to a very nice clean JavaScript at the I'll show you how that happens when we see that. And what do we mean by superset? Again, you have ES5 sitting at the bottom. This is what everyone uses. And then you have ES6 features coming in, and then you can also adopt ES next features, and then anything that comes around that, and you can have your own special types. So TypeScript allows you to foresee into the future and adopt features that will be ratified in about 2 years, and you can start using them now. So things like async await, which was just missed from the release candidate a couple of days ago that went out. It's going to go out to the 2.1 release, which is earmarked for a couple of months ago. However, async await is nowhere near available to plain vanilla JavaScript, and that's quite important. Okay, so TypeScript will generate JavaScript that will run on any browser, on any host, and on any operating system. And not only that, but you can also write TypeScript in the same way. So you can write it on any operating system and on any host. It doesn't have any requirements for .NET or any subsystem in the dependencies on the Windows operating system. You're free to write anywhere. In fact, most of the times I do the demo, I'm doing it on a Mac, just using my normal Visual Studio Code. And the stuff I'll be showing today are going to be done on Visual Studio Code, which runs in exactly the same way as you would do it in Mac OS or Linux. All you need is Node and the TypeScript server. So 3 things about TypeScript I love. It's open source, so it's developed out in the open. You can go into the TypeScript repo on GitHub, and you can have full transparency on the features to come, on the progress, and you can even contribute if you have any input on how things are progressing. The second thing is that it combines the good things of JavaScript. So JavaScript, the good parts. I think someone was walking around with the book today. There you go. And it gives you the tooling and support and the language features that you would get from TypeScript. And then you get the best of both worlds in order to allow you to write good code that compiles into clean JavaScript. You can control a lot better. And there you go. We just give the JavaScript good parts. This is what you have in the end once everything transpiles down into JavaScript. Again, I'm going through the slides quickly because I think it's more important to focus on to the features that we're going to be seeing afterwards through the demos. But I'll give you a brief explanation about the stuff that TypeScript adds as a language. So first of all, you have structural typing and type inference. So I'll demo that easier later on. However, it works out what kind of types you assign to a variable, and then it will say, well, this looks like a string or this looks like a number. And then when you use it further down into your code, if you try to say int.length, then it will say, sorry, mate, this doesn't work out. It's an exception. And you get compile time errors, which is fantastic. You don't have to run your code onto the browser just to figure out that, you call something that you shouldn't be calling. You get nice squiggles underneath and error messages, as I will show you later on, that help you solve the problems before you even run your code anywhere else. You get generics. Anybody knows what generics are? So strongly typed collections and strongly typed types. So you can say this is of type car, and then every time you create a collection of things, it expects them to be car. So you can define that in advance. So again, you work with the strongly typed features that the language has to offer. Again, it works with existing JavaScript languages and libraries. There's a declaration file that you get. This is called typings in general. So it's library definitions for different frameworks. So if you guys are working with Angular or Aurelia or React, you get an equivalent typings file, like a header file, that will give you IntelliSense when you work with that. So in fact, you don't even have to use TypeScript. Let's forget about TypeScript. Let's say you just want to work with JavaScript and you want to have IntelliSense. IntelliSense allows you to say variable dot something, and will give you the dot, will come up with options about what you can attach to it. So you can do that. And that will work for anything that, I think there's a massive repo. It's open source. It's open source maintained as well. So anybody can contribute and fix things. And it supports most of the frameworks. So even if you don't use TypeScript at all, you can use the typings files to help you write code faster and help you with IntelliSense. So you can be a lot more productive with this. However, if you are going back into TypeScript, then obviously you get other benefits. And enables a lot of tooling. So not only do you get the IntelliSense through your text editor, but you also get other tools that can be add-ons to your editor to help you be a lot more productive as well. And that's also the compile time errors that you get, which is the biggest thing, I believe. So next, we're going to be talking about classes, interfaces, and modules. You know, we have namespaces now, like in .NET, which allow you to encapsulate something and make it specific to that, so you can have encapsulation for methods and properties that you wouldn't have otherwise if you were transpiling everything into one file. That can be a bit of a problem, but you can also reference and import those namespaces into your file so you can get the features. So it allows you to segregate your code in logical units to make it a bit more functional. It's scalable application structuring. So you have classes, interfaces, and modules, which allow you again to construct your code in a specific way and make sure that when you define a class of an animal and then you create a cat, you want that cat to be a type of animal, or you want to extend that class, that base class, into something. You can inherit from interfaces, you can enforce contracts into your code, so you know that if you are creating a class that implements an interface blah, then blah has a method called go and get or send email, for example. Then it will force your inherited class to actually implement that method. It's aligned with emerging standards. So TypeScript is not going on its own to create its own types and stuff, but it works with closely with the ECMA script committee to make sure that what comes in is what is going to come out in a few years. So we're not adding features that shouldn't be there. So async await, as I explained, it's due to come out in a few months, depending on when 2016 will be ratified. However, TypeScript will be offering it to you a lot sooner, and that will be compiled down to ES5 compatible code that most of the browsers understand today, not even ES6. So we're not even in the greenfield browsers that most of the people experiment with, but we're into the Edge and IE12 that nobody really wants to use, but they have to, and they're forced to. Did I say that loud? I work for Microsoft. I use Chrome, I use Safari, I use quite a few browsers. So, in fact, I did my interview on a Mac. I had to do a presentation and dropped in with a Mac, which was a bit odd, but they're quite changed to what they were 5 years ago. So we discussed also about popular modules. So you can choose whether you want to compile or transpile your code to target a specific module like AMD or CommonJS or Node or System, or anything that gets added in the future will be also forward compatible. So with TypeScript, you get that kind of backwards compatibility. So we don't only support the back or the historic stuff, but we also support the new stuff. So you get the best of both worlds. And obviously now we do quite a few things. In the past, when you had to say, I want these files to be transpiled into JavaScript, and you have one master.js file that will be outputted and referenced from your HTML file, you had to say, I want this file, and then this file, and then this file. Now imagine having 100 TypeScript files there doing different things. You had to reference them in a specific way. Or the other way was to not reference any of them, and then everything will be included. So that was the very early version. And then 1.6 added the support to say, I want to add everything, but I want to exclude these. And now what we do is we support a wildcard definition. So you can say, I want to include everything that has star.ts in a specific subfolder, but I also want to exclude things that like tests, because I don't want to transpile them into the same file that would go out into my HTML file. Right, community. We did say it's open source, so it's not just Microsoft doing things and then putting them in the open. We do actively accept the contributions from the community. These numbers are fairly old. I think they're about 3 months old. So if you go to GitHub now, you'll find a lot more community contributions. But even just to show you the extent of that, we have 827 forks with 500 feature requests. There's a lot of activity on Stack Overflow as well, and 1,600 pull requests already closed, and that's an old number, as I said. Now, we did discuss about frameworks and support, so that's the typings I was saying. We have over 1,300 typings files, which are the definitions around your language for Angular and Aurelia and Backbone. Most of the big ones that you are going to work out there today definitely have typings. It's quite unlikely that you won't find any typings. And tool support. We do support a massive range of tooling. So you have Monaco, Eclipse, IntelliJ, Resharper, Sublime, Atom, Brackets, and you can build it on Heroku, Ruby, Grunt, ASP.NET, Node, anything that you like. You can use it. You don't have to use Visual Studio just because it's a Microsoft product. In fact, I don't even use it for TypeScript stuff. And testing, again, supports lots of things. Roadmap, we have 1.8, which is currently the stable release that you get when you download TypeScript by default. You have a way to override that by saying node install -g and then TypeScript at RC, and I will allow you to take the RC bits, which were just released a couple of days ago. And 2.1 is coming soon. This is going to include the async await, which is so important. Everybody was expecting it to be out in this release. However, it's going to be out there. Polymorphic this and so many other things. And if you want to see where the roadmap is going, there's a nice page on GitHub that will allow you to do that. I think we're just hit at 20 minutes now. So I'm going to leave you with this. And if things don't work later on, it's not my fault. It works on my machine, as people tend to say. Or I have a couple, but that's fine. So I'm going to be using Visual Studio Code today. Can you please let me know if you can see the stuff at the back? We already tested it, but just making sure. Good. Okay. So again, Visual Studio Code, I already have some pre-made code over there. I'm not going to type while we're here because that will take all 20 minutes. I'm a slow typer. Typist. But Visual Studio Code, why I like using this one is because it can actually have a build system. It gives you compile time errors and also works really well with TypeScript and has its own build system. So when you create a brand new solution, it will come up with a thing saying, oh, I think you're using TypeScript. Would you like me to create something for you to be able to compile TypeScript? And then if you see that VS Code over there, it has a task underneath. And that task, it says my Visual Studio Code, how to interact with TypeScript and what to do. So in this case, it says we're running a TSC command, which is the command that compiles TypeScript into JavaScript. And we're passing a P, which is we want to compile the whole project more or less. But TypeScript, if you're working with TypeScript, you need to have a compiler option. So that's a tsconfig file. That's your main solution or your main project definition that says, I'm going to be working with TypeScript. We want to create source maps, which is something that gives you, if you are minifying and if you're compiling your code into small chunks and compiling into one thing, when you go into your browser and you deploy, you want to be able to compile and step through your code. So this is what your source map files do for you. You can remove comments from your source code if you want to, so it will just go and wipe out everything that it's a JavaScript comment. And in here you can also target different modules. Now the nice thing about this thing is that you can say you can get full intelligence here. So you can say I want to compile either against ES3 or which is the default one, or ES5, and it will just work like that. We also have different modules that we can target. So you can say I want to target things like, now you get full intelligence here that says these are the options that you are available to you just now, and as things are added, this will be becoming a lot more advanced. So in this case, we'll just go with AMD. It doesn't really make any difference. And you also get a comma over there. Experimental decorators. This is for decorators in JavaScript. We do support that, and it's not a feature yet. However, we say you can play with that, and we will support it within TypeScript. It will get compiled down into proper JavaScript eventually. Now, the out over here, which I have commented out, allows you to take all your TS files, compile them to JavaScript, and then put them into one file, which can be whatever you define. It can be your project.cs or your main.js or whatever you want it to be. In this case, I will leave it out because I want us to see the different files that we're working on with the modules side by side. So as you can see, I only have TypeScript files there. I don't have any JavaScript. And now Control-Shift-B allows me to build everything. You see it spins down there, and then soon we get poo. Everything is out. So we get our TS files and the map files, which are allowing us to debug the code in the browser. However, we're going to be using Node here to play with the files. Now, I'm going to start with datetype.ts, and I'm going to hide this. I want to open the TS file side by side. So we can have, let me just close this one down, and I'll close this one down. We don't need it anymore. So I want to have both of these side by side. Close this one down, make some more space for you guys. And now you can see them side by side. So on one, so I don't want that one. I want my TS file. So you'll see on one side, That's our TS, our TypeScript. On the other side, we have our JavaScript. And as we change things, you'll see that they change eventually. So first thing to notice is that we can define different types. We have Boolean, number, string, and array. And when we say an array, we say, I want a list, which is a number. So when you hover over it, it actually knows what kind of type it is. Now on the other side, it has no idea what it is. It's a proper JavaScript. It doesn't have any notion of being a number array. However, as we work with code and we try to add stuff, so for example, if I want to go to do type string is not assignable to a type number. So this is very important. It won't allow you to mix your items over there. So sometimes you do get in JavaScript, you want to have an object array. However, if you want to have a strongly typed number array, then not only does it allow you to define it, but it also protects your code from assigning stupid things there. Sorry, I meant to say silly things. So we also support enums, which it's a feature that was not easily supported. You can see what it outputs here for the equivalent JavaScript. Now, one thing I really like about TypeScript is the cleanliness of the JavaScript that it outputs. It's not just junk and a lot of code and wrappers around it. In fact, it's one of the cleanest outputs that you get, even better than Babel, I think, although I haven't really worked to that extent with Babel. Now, one very, very nice feature over here is multi-type. And what multi-type is, it allows you to create a type that can be of two things. You can have a success or failure type kind of a object. And then depending on that, you can infer what you want to do with that object. So for example, if I were to say I want to have a multi of string, it does not accept it because it only accepts numbers and booleans. So you can have true, false, and a number, but you can't have a string. So the beauty with the multiple type is they can have a workflow that allows you to do different things depending on what the type is passed in, and it will infer it at compile time. So it knows that. So you can say if it's a number, do a calculation, but if it's a boolean, then do something else. And you can do it all in one function. You can have complex types, as we discussed. So you can rather than creating a class, it will create it on the fly for you. So it knows it's a person with a first name and a serial number. That's a very American one. Obviously, you can have void objects. Usually that's assigned to methods that you don't want to do anything. Sometimes the methods can return an int. You can expect that. Or sometimes you want to say, I don't want to do anything. I just want to output a message. We'll run this later on. So again, type assertions. TypeScript introduces this thing called any. And in fact, you can say, when I compile stuff, I don't want to support any. So if anyone in the team likes to be unsure about what they're going to pass at some point, they say, well, we'll stick with any. And that's quite common, especially when you work with Angular and other things where you pass things that can be anything in real time. I worked in a team that eventually decided it was quite bad to pass any anywhere. And rather than saying at code review time, oh, you don't really want to pass any, we should be passing a proper object, what we said is, we're not going to allow any anymore. So when you compile the code through Visual Studio, it will say errors, and then you can't really check in the code. So it was quite nice. However, if at some point you want to support any because you don't know at that time what it is, then it will do so. However, when you, so you can see here that it knows it's an any. And or even though it's a string, it's not inferring the fact that it's a string. It will say, it will keep it as an any because you defined it as any. Again, what happens here now, let me just scroll over here. So the any will compile to something. However, some value any. If I change that to be a number, you'll be surprised that it doesn't like it because now number doesn't support length. So it's an any, but when you cast it into the right object, it will throw up the nice error messages there. And as I said, with IntelliSense, you get a full list of all the properties that you get for a number or a string. And a string there. We have tuples as well, so you can have, I think we now support a new object called nothing, which it can be anything. It's almost like any, and there was a massive debate on on Twitter the other day that people were trying to understand, and it was mainly coming from the F# community that are quite functional. They were trying to figure out why we have a type called nothing. And I haven't had a chance to play with that, so that's why I'm not going to demo it today. However, we do have another thing that allows you to enforce based on the type. So we say the type digit can be a multiple object that can support any of these values, which are all numbers. And you can see that now we define a nums property, or a numbers property, that it's a type of digit and has these values. However, if I were to do, so I already have it here. So if I were to push 16, it will say, well, 16 is not an assignable parameter to type digit. So that also enforces you to accept only a subset of values if you want to, say months of the year, something like that. Quite clever in that way. And if I comment that out, and I save that and build it, and outputs no errors. And then if I come here and say node 01 does, so this is my warning message. So this is what the file will run when it runs. And let me move to the next ones now. Any questions at this point? Feel free. No? Good. Next one is quite similar. In fact, we're doing the, no, don't want the map. We're doing the type inference and the type inference, put them side by side, hide our command output. Now, type inference is quite nice because we did say that at compile time, we'll work out what your variables are. So in the first one, let me go to the top over here as well. In the first one, we are actually inferring that x is going to be a number. So if I hover over that, sorry, it should be x. It says x is a number, if you can all see that. On the next one, we are inferring based on the majority of the objects that we have in there. So we have 2 digits or 2 numbers and a null. So it will say the majority of my objects in there are a number. So if we hover over the y, you see that it says it's an array of numbers. So that's another way to infer if you're not sure about something and you have you passed a number of objects. Obviously, if you want to have an object, you can say an array of any's, and then that will accept a wide variety of objects there. However, working with TypeScript, you should be a little more explicit about what the objects that you're putting in your collection. Now Z is an any because we haven't really defined anything for Z. So it will say my Z property is an any. Now let me just hide this out a little bit. Do you still want me to show you the JS file, or are you quite happy with what we get on the TS and show you that? Just to make some more real estate space here. So on the person that we're passing in here, it's an any, so it doesn't really know what it is. However, it doesn't throw an exception when we say person.name because it doesn't really know that name doesn't exist there. However, I would avoid doing that because, again, we want to be more explicit with what we type. Again, a number, we've explicitly said that. When you create functions, now that's a nice one. You can say, I want my functions to take these 2 parameters, which should be a number. So your parameters can be anything other than a number. And you can also explicitly say that the output is also going to be a number. Again, you are being very more explicit. So static typing there, fantastic. So if you try to add something that's not a number, hello, it will say, sorry, but you can't do that because string is not assignable to number. And the return will also be inferred. So sum, because we already know that the method returns a number, it will automatically say that the sum is a number. And then you can use it further down. A little bit of string interpolation over there as well. We do support that. Get VAT again. Return person.vat here. What else? And finally, VAT, get VAT. Any questions so far with the type inference? No? Let's move on to the next one. Functions. Obviously, I want the JavaScript, I want the TypeScript. JavaScript is all about functions, so we do have really good support here. Type function at the top, you get a specific explicit parameter definition and output definition. Anonymous functions as well, so you can do it in the normal way that we do functions in JavaScript. As I said, it's very, very common to JavaScript. It does support let, var, and const, so the new things are coming in through ES 2015. Function type, so again, it will work with lambdas, and we do support lambdas and such, so it doesn't have to be that. It can be a lot more complex than a lot of things. Let me see. We do have default parameters as well, so you can have a default parameter. So if you don't want to always pass the last number, you can omit that. And the nicest of the things is the rest parameters. So if you want to say the first one, I want it to be a string, but anything else can be of an array of strings, or it can be an array of any, or it can be an array of ints. So you don't have to explicitly say I want 20 more parameters, and you don't have to anticipate for the next parameters that are about to come in. Arrow function, again, we did say we support that, and we support complex operations on the arrow functions. This operator, again, we do support this, and it will respect the same way that it gets respected from the lambdas. So whatever ES 2015 does, we do have the exact same behavior. So you should be confident about this. And I could run this one as well, just to show you that it all works nicely. So if we go up. Go ahead. The backticks. You mean if I go up? Oh, this one. That's how you're allowed to do string interpolation. So now this is a normal string that will be outputted out there. However, because we have that, we know that if you type this name, why it's not giving me the? Should be able to give me the setting. I would expect the IntelliSense to pop up here. Okay, so if I go back to the previous file, let me go to type 1. And I think I had string interpolation here as well, no? That's a bit odd. TS here. So if you see that one, can do some dot. So it will give you full IntelliSense within your string, so it will allow you to do things like dot to length or something without really having to do close brackets plus whatever it is and then do whatever you want to concatenate your strings. It allows you to reference your variables in a strongly typed way. Right. Function.js, function 3. So this one's about, we already done functions, yeah. Let me just move on to interfaces because I'm conscious about time. How done with time? You're all mesmerized. You like it. I'll carry on then. We're good with time. So interfaces. Interfaces allow you to provide a contract to your objects. So if you have a class and you want to say, I want to always implement the iPerson that will have a name, a username, and a password, and a method that goes change password, then if you define a method called print, if you define a new object, then that object will need to implement all these. Otherwise, it will not compile properly. So in this case, we have an iEmployee that implements iUser and iAuditable. So if I remove that, or if I comment that out, it should complain about when I build it. Or not. Or not. It doesn't complain about it. Probably that might be, that's because it adds onto the actual parameters rather than implementing them. So employee class extends auditable and iEmployee. So extending means it takes a base class and builds on top of that. If you're talking in object-oriented code and implements it, actually implements the interface that it's being passed into it. So it should be. I would be expected to throw the error messages. No, okay. Must be doing something wrong. The idea, however, is that you can have multiple objects that inherit from multiple objects and then multiple interfaces, so you can enforce behavior to your objects. So I'm pretty sure that. Yeah, okay, so partner class implements the iPartner interface, which also inherits from a number of interfaces. However, if we hide the change password method, which is part of the iPartner, then it throws up an error message saying you have not. Partner class incorrectly implements the iPartner because it's missing a specific method there. So that also allows you to have strongly typed objects which have a specific behavior as you would expect it to be. Now, classes are also supported by ES 2015, but you don't have interfaces, and you don't have namespaces, and you don't have multiple inheritance. So it's a lot easier to implement it like that. I mean, if you see the generated interfaces code, it's definitely not something I would write by hand and be happy about that myself. So there's a lot of code there, but it's all hidden away for you in a nice abstraction. So again, let's go to classes. And classes, again, not something that is quite nice to look at, but you don't have to look at that. I mean, you can easily work with that code because it's understandable. However, it's not something that you would easily write, especially for people that come to JavaScript from an object-oriented environment like Java and .NET. It's quite hard to wrap their head around how functional JavaScript can be. Whereas with TypeScript, they can combine the best of both worlds and get the productivity that they could be getting otherwise. So going to the classes.ts, again, classes, as we discussed earlier on, they do the same thing. However, you do get things like constructors and public and private methods. So you can have a public accessor to a property, which can be referenced later on. So a public model of type string, and that can be referenced outside your class. However, the private ID, you won't be able to reference. And if you try to do that, you'll get a nice error message. Again, the car is a new vehicle. We define that with a new the new keyword, which is a constructor, and then we call the methods into that. It has full intelligence. So if we were to add a new method saying get mileage, I'll just say return 100, and then because that's an object, that's part of the vehicle now, we can say car.getMileage. And you get also full intelligence there because it knows that it will return an integer by inference. So really powerful stuff. Again, I said the constructor. I also mentioned about private and protected properties over there. So you get the encapsulation of object-oriented programming into your function. Now, if I were to show you the equivalent in JavaScript, it will raise some hairs there. Right? So you can see how the same motorbike, which is extending the base class, looks. I mean, there's no constructor over there they can easily work with. However, it is there, and you have to mess with the prototype and so on. Much easier to work with I think, with TypeScript. My preference, anyway. So decorators as well. No, not that. No idea what's happening there. So decorator function, you can, what happens if you do that? So you can return this, you have to return the fun. So this is where you add changes to the actual prototype in that way. So the change name will be added as a decorator into the original method, the original object, without having to go back and change the class. However, this shouldn't be used in a big extent because it makes your code a lot less readable. Whereas if people say, well, I'm working with a type of myPerson, and you go into that myPerson class, you can see all the methods there. But sometimes it's quite handy when you want to extend the object nicely, and allows you to do it in a strongly typed way using the decorator properties. How are we doing with time? Okay, I think I have generics, as we discussed, and then that's my last one. Yeah, so that's the second last. So generics is also quite important. This is something I really like. Again, coming from an object-oriented environment, especially in C#, generics is a very, very powerful tool because it allows you to do a lot of strong typing around your objects. So in this case, you can say do something on an object which can be of type T, and then it will understand what the type T is based on the type that you pass. So over here we say do something with a string, and it will allow that to work as expected, and then do something with a number. And in fact, if we were to have different parameters in here, or different return times, or different operations, you would go and hit the exact method that you're supposed to. I think one thing I've missed with the methods is the method overloading, and I would like to apologize for that. So if I go back into functions, so function overloading, it's at the bottom. So you can do this, which is a bit of an odd look. So for function titled case name, you can have all these three types defined in the same way, and depending on the parameters that you pass, it will accept them as long as it fits into one of these three, and you can have as many as you want, cascading one on top of the other. So you can have method overloading that we get in object-oriented development in the power through TypeScript. Let me just go back into our generics. You can also have array types for generics. So we can say get length for t, and then depending on how many parameters you pass there for an array of t, then it will work. So for example, if I were to run the get length for this one, in fact, let's just run this one to showcase the results. So that's the 7, isn't it? Yeah. If I do, hey, error, yay. What is not like type inference.js? I think I changed something I shouldn't have. Do you want to save changes? No, don't save changes. Don't save. Okay, going back. Yeah, let me just rebuild. There might be an error there that I forgot to fix. Okay. Oh, is it? Oh, yeah. Wrong file. Generics. There you go. So generic type length is 1. Generic type param length is 3. So if we go back into our generics file and look into the output, I don't want the JS, I want the TS. Thank you. It insists, it wants me to work with that. So you can see the output that we get from here is, again, it's a generic, so it says output 1 is 1 and 3. And here we have one string into the array, one item, and number of 3, and so on. So it works with the strongly typed parameters that you pass in. It can be a lot more powerful again. It can have different definitions on, you can pass different types and so on. And you can create your own generic types as well. Extend things. Now, for example, we have a vehicle, a car which extends vehicle, and a motorbike that extends vehicle. And if we were to say print model birds, because birds does not extend from vehicle, you automatically get birds is not a type of vehicle, so it doesn't satisfy the constraint. So not only you get the generics to work with, but you also get nice error messages around how you use those generic classes. And finally, namespaces, which allow you to, I just want the TS, right. So namespaces are more or less modules that you use in, and in fact, we had modules in the past in TypeScript, but they renamed them so people don't get confused between modules in Node and other frameworks and nodes in TypeScript. So now we have namespaces, which more or less match the .NET definition of a namespace, which encapsulates a set of functionality within a namespace, and then you can export specific things from there. And then what happens is when you want to use that namespace into your code, you say import namespace blah, and then it will bring all that code into your, or classes and definitions into your TypeScript. So you can reference other files more or less in a strongly typed manner. And I think that's me. That concludes all the tests I had. Are there any questions I can, are we good for questions now, yeah?
Yeah,
cool. Any questions? Over here, I have one.
Hello.
Hello.
So CoffeeScript has kind of tried to do a lot of these things in the past, a bit not typed, but try and improve JavaScript and extend it.
Sure.
And kind of that ended up getting left behind a bit by the development of JavaScript. What would be your argument for saying the same thing would happen with TypeScript?
I can't really foresee into the future. However, I'll say this. The Angular 2.0 is actually written with TypeScript.
Okay.
So that should give you enough foundation to have confidence in the framework and that it's going to be supported for the long run. I hope TypeScript 3 is not in anywhere in anyone's sights. So TypeScript is not only used for, to support other frameworks, but it's also used by the biggest framework out there to be written on top of JavaScript and TypeScript. So you get that, you get a lot of tooling as well that is written on top of TypeScript. So people are actively adopting it. One of the benefits of TypeScript, again, it's not that it's been developed by Microsoft, but the fact that it brings all this object-oriented methodology into TypeScript, into JavaScript, means that a lot of developers that were back-end developers and they didn't even dare look into JavaScript, now they have a lot more confidence about going out there and writing apps based on JavaScript or running on JavaScript. But they use the knowledge that they already have. So they bring that knowledge into it. So I suspect that as more people get into the habit of using that and seeing that it produces performant and easy to manage code, it will be adopted a lot more.
Cool.
I hope that answers your question. There's another one in the back over there.
Sorry, it's kind of following on from what you were saying.
Yes.
Do you see back-end stereotypical computer science majors kind of taking over the stereotypical JavaScript developer? Or do you see stereotypical JavaScript developers maturing more into the role?
I would say both, because TypeScript is not a new framework or something, a totally different tool that you write in a totally different language and you have to learn all over again. My hope would be that more people will use it. It's very lightweight to start with. It doesn't impose any heavy load into your code. It's not a framework that you have to install. There's no add-ins or anything else. So it's quite lightweight to play with. If you don't like it, you can always discard it and keep the generated JS files that you get there. Also, what you say, because existing JavaScript people can just take the skills and bring them into TypeScript and just get the benefits out of that. It also means that it's not alienating either side. So I would hope to see a lot more back-end developers coming into front-end. Obviously, there needs to be a little bit of structure as well, because we have frameworks and patterns and all these things that need to be adopted. So it's not just a wild, wild west being able to write JavaScript somehow. However, it makes the transition a lot easier. And I have to say, I've seen bigger projects adopting JavaScript as like Angular, rather than saying we'll go MVC .NET, because that's what we can do in C#. And what they do is they create a thin web API layer, and they bring the JavaScript skills into it by using TypeScript. So you have .NET developers doing a lot of JavaScript because now they can. I was one of them, to be honest. That's how I started using JavaScript in a massive scale, rather than saying button click, do something. That was the first time I actually adopted a much bigger JavaScript project. So there you go. I'm a living proof that TypeScript works. Any other questions? There's one over here.
Hi. Since JavaScript is a bit functional, is TypeScript functional as well?
It can be totally functional. You can write just pure functional code. You can have just functions with lambdas that do something, and you can have. We also had, before async await came, we had a lot of promises, so we're using promises, and it wraps things quite nicely for you. So you don't have to write classes. Again, as I said, if you want to be full functional with vanilla JavaScript, you can just use it here. The benefit is that you get the intelligence and the tooling support to allow you to refactor and change things. And I mean, I can come in here and say with full confidence that anything that has a type of iPartner, iPartner, change it to, so you can find that. You can also do things like, obviously that's not the only thing that supports it, but the fact that you can take a class and move it into a different method, into a different location into your file system without having any fears of breaking stuff around, it does bring quite a few benefits there.
Okay, thank you.
Just got one last question before we wrap up. Just pass it to.
I'll be happy to take questions after if you want to.
Hi, nice presentation.
Thank you.
I'm just curious about how the language is developed itself. So obviously JavaScript has a committee, and you put suggestions forward and things like that. Python has the PEP system to take it forward. How is the TypeScript language actually developed? Is it just Microsoft's thing?
No.
Or is it a community developed effort?
So as I said in one of the slides, the TypeScript team works very closely with the ECMAScript committees to understand not only what's currently in progress and available, but also what's to come in 2 or 3 years' time. And in fact, what you get with, I think 2.1 adds features that won't be available until 2017 or 2018. So these are things that it brings into. You don't have to adopt them if you don't want to. However, if you want to be experimental and do stuff, it will allow you to take all these new features that the committee is working on, that might not have been ratified yet, and then bring them into the current development and make them compatible to ES3 and ES5, because we can target both. And if they don't get ratified, then you don't have to stick with them. However, you need to be careful on how you adopt new. Like if you're adopting very experimental stuff, and you say you saw over here in the definition. Let me just go back to my tsconfig file. We say experimental decorators too. If I said no, then that's one of the features. So there's a lot of flags out there. In fact, there's a massive list of. If I were to type something, you see these are all the flags you can set in and out. A list emitted files, map root, definition, no emitted helpers, no implicit any, and no implicit this, no implicit script, strict, and so on. So you can be quite strict with how loose your TypeScript is. If you want to be very, I want only to support ES5, but in an object-oriented way, you can stick with that. But it will evolve as ECMA script committee evolves the language, and hopefully we'll see them working side by side for the long run.
Thank you.
Thank you.